Howdy. I check 1, 2. Howdy from Dugway Proving Ground. I'm Dr. Croft. This is the Sample Return Capsule Day for NASA's OSIRIS-REx, America's first asteroid sample return. The mission goes on for over 20 years, as it was first submitted to NASA in 2004. It was not selected. They resubmitted in 2005, 2007, and in 2011, on the fourth try, NASA selected OSIRIS-REx to launch in September 2016 to the carbonaceous or C-type asteroid, Bennu. NASA also had a campaign for students to name Bennu. It was named by a elementary student several years ago. The spacecraft blasted off of Earth in 2016 and arrived in 2018. Images and maps were made of the asteroid throughout a few year time frame in order to identify a location where you could pick up the asteroid sample. After careful selection process, 4 locations were narrowed down, and the sample location named Nightingale was selected for sample return. The Touch and Go Sample Acquisition Mechanism, or TAGSAM, as it's lovingly named, touched down in October 2020 to grab over 60 grams of material from the surface of the asteroid. We were so successful that the capsule wouldn't actually close. Material was blasting out. Eventually, they got it closed, securing many, many grams of material. That was closed in October 2020. And on May 10th, 2021, OSIRIS-REx jettisoned and left the asteroid Bennu to return Bennu sample back to home Earth. The spacecraft's been in orbit on its way back to Earth. And the sample capsule is already detached from OSIRIS-REx and on its way down. It should hit the top of the atmosphere at 8:41 a.m. Mountain Daylight Time, where we are here at Dugway Proving Grounds here in Utah. The view that you see here is off towards the direction where the 4 recovery helicopters have flown off to retrieve the sample. We are at a safe distance here, and I'm hoping my zoom lens can get as far in as it possibly can to get you the action shot. It'll be 14 from when it touches the top of the atmosphere, trajectory down to hit the surface of Earth. It has a parachute in order to slow the landing. As of this morning, there are absolutely no attitude adjustments needed, and the trajectory is looking to be spot on and perfect. Principal Investigator Dante Loretta spoke to me this morning and assured me that everything is looking perfect. Not only is this the first asteroid sample to return to Earth or on the American soil, but the OSIRIS-REx mission technically ends today, but the spacecraft has been repurposed and revamped as the Apex-REx. Now, the spacecraft has enough fuel to travel back out to where asteroids are located in our solar system, and in particular to the asteroid named Apophis. Apophis is an attention getter because for some time we had some speculation that Apophis might intersect Earth in 2029. But this has been proven that it's unlikely to hit Earth, but it's still a very good idea to go study Apophis in greater detail. This is the greatest use of United States taxpayer dollars because we're reusing the spacecraft. It's got enough power to go do more science. Although there won't be a return sample of Apophis, we'll get images, high resolution, maps, radar, gravity data, and will also help us understand the category of Near-Earth Asteroids, or NEAs, as asteroid Apophis is. And in fact, asteroid Bennu is also a near-Earth asteroid. One of the main selection criteria for OSIRIS-REx in looking for the target. Not only is it interesting to study and refine orbits for potentially Earth hitters, I won't say dinosaur killers, because most of the solar system is cleared out from the large catastrophic impacts. Good thing. But we still want to know what sort of impending asteroids could eventually hit the surface of Earth potentially. And so studying these near-Earth asteroids, or these NEAs, are of great priority for NASA in general. Okay, we're officially 1 minute away from it hitting the atmosphere. I'm going to keep my eyes peeled for the entering trajectory and do my best to zoom on in, and then I'll do my best to also answer questions that are popping up in the YouTube live chat right now. If you're just now joining us, we're gearing up for the return sample of asteroid Bennu from the OSIRIS-REx mission, NASA-based mission. Okay, so we're a bit far out from the true recovery area for safety purposes. So I'm going to be panning and looking for the entering trajectory of the sample capsule. Yes, it does have a heat shield. I'm sorry, I don't know the exact material. I know someone just asked about that, but we can research that later. And it does have a heat shield on the bottommost part, parachute on the top. All goes well. That parachute slows it down. And then what will happen is they will walk right by the frame that you're seeing here, sample, which I'll also stream. All right, I've got some NASA words in the background. I hear some cheers. I think it's officially entered the atmosphere. So it might take a moment for us to see it at this scale size from our location, but I'm going to do my best here from our distance. I hear lots of cheering, lots of cheering. Things are going good. Find it in the sky here. When it entered the top of the atmosphere, it's moving 22 let's see, 1,000 miles per hour. 22,000, yeah, quite fast. Hang tight, we're currently viewing. Oh, I think I've got. Hang on. The moment I saw one bright object, let's see. Is that it? That might be it. People confirm, is that it? I think we found it. Hang on. Get the focus here. No, that's not it. Ah, okay. Hang tight, crew. We're looking for our visual still. We've got a NASA plane observing up high. See if I can get that in the shot.
It's our contrail. It's a beautiful morning. The sun is up, finally it's been chilly earlier on, and we're waiting. In that direction.
Ah, clear? Hang on. You can see something right there. That's looking like a fall. All right. Is that it? That's the plane, but I saw something over here to the right. Here we go. There it is. Okay, it's real faint. It's real faint. I think that's it, guys. Hang on. Let me zoom in. I don't know what else would be falling from the sky today right there. Let's see.
Subsonic, and then a little while after that, we will see green sugar.
It's very faint. I bet this isn't a nightfall.
I don't see it.
Let's see. This gray villa building, and then up to the right.
Oh, okay.
Right there. I think that's it. Sorry, getting on YouTube. I'm trying my best here. Let's see. Quite faint. Okay, it's like a very faint streak. Looks like it's coming from a north to slightly south trajectory. I need a much higher lens, power lens here, so it's gonna be more exciting for y'all once I film when the sample walks by right here. You can see that little streak here. Okay, I can't even see the streak with my own eye anymore, FYI. But at first it had a vertical structure to it, and then it had a more of a from north to south trajectory. Okay, so it's gotten quite faint for us to see here, so I'm going to see if I can answer some of the YouTube questions until we have our main walk by of sample, which will occur right up here. See if I can answer some of y'all's questions here.
So how is it today 70% planet Earth and water comes from? Was it delivered by astronauts like that way back delivered complex that helped life. That will be preserved for largest problem not important work the project not even built using instrument. So that was at the very long go back to your they still got the archive. Some of that stuff hasn't been reviewed years old.
Okay, we've just heard word. It was a successful touchdown. So again, they're off a couple miles away. That's why it was kind of hard for us to see from this location. But we will be filming right here when these pass by us. The helicopters will bring it back. Sounds like it landed at 8:52 a.m.
So it's time to turn this planet a little bit ahead of schedule. The important thing is that it's around about 10 miles to go to your question about how long was it the mission was launched 7 years ago. It started back then, it would take about 5-6 years to build the spacecraft. Scientists involved, we've been sort of devising, planning, for a good 10 years. The investigator, Dr. a couple of days ago, worked for nearly 20 years. We saw him actually get thumbs up yesterday. I didn't even get to go out covering positions. What a moment for him. See it all the way from now to the moon. With those pressure samples, like must be well shot. And prospect actually all the way up to the stars.
So there was a question about the heat shield. So it is a plastic resin layer that's designed to carry away the heat as the melting layers experience the friction from the atmosphere and heat up. And so the faint streak that I could barely see, apologies that our camera and our distance didn't quite do it as much justice as it could have. We're, right below it, of course, small capsule. But as that experience the friction of the atmosphere, the plastic resin layers peel away, and then kind of give you that classic streaming look when you falling through the atmosphere. It was a very faint streak that I could barely see for a few moments here. And so up next, what will happen is they're getting the capsule in helicopters. One of them being a NASA helicopter, and they will come and land on the helicopter pad here right in front of us. So if you're just joining us, this is Dugway Proving Ground, located in Dugway, Utah, out in a remote part of the desert, where a lot of testing for the U.S. and landing of capsules can occur. And so the helicopters will land here, and then us media crew are able to see the capsule pass right by. So we're going to hopefully have a close-up look of that burned heat shield. And so the helicopters will come from the distance, the direction where the frame is pointed now.
It's actually more than to do with almost with single atoms to learn about what the early results they need to do it in the environment. Otherwise, you're going to find
Okay, so now we're waiting on the helicopters to bring the capsule material over to this area where we're posted up here. I've just heard they found the parachute on the ground as well. If you want to see an example of a parachute not deploying correctly, here at the same location in 2004, there was the NASA Genesis Stardust mission where NASA attempted to grab grains, small grains from the sun, and parachute only half deployed, and so it's sort of, crash landed. Not the case today. Not the case today. The parachute is good. Sounds like they're recovering it. They should be getting on the helicopters soon. One of them being the NASA helicopters that the astronauts used to train with. Same helicopter that the astronauts trained when we filmed a few weeks ago for the NASA Crew 7 launch. So the NASA helicopter gets some good mileage. Let me see if there's any more questions I can answer while we wait.
We should also talk about the OSIRIS-REx spacecraft, which worked at the sun a few years back and put it inside that capsule to come back to Earth. Now, it carried the capsule back, let it go over the capsule about 4 hours ago. Then it had to make a very good move because it just carried off particles.
I saw a question of what is an asteroid. I like to call asteroids the crumbs of the solar system. They are leftover material that just didn't quite fully form into planets. Let me see if I can get in front of the camera here. Believe that I'm a human here. Not alien, I promise. The asteroid Bennu is a carbonaceous asteroid. We typically have ones that are more carbon rich, ones that are more metal rich, and ones that are more silicate rich. A lot of rocks on Earth are silicate rocks, and other asteroids in space are silicate rocks. Carbonaceous asteroids make up the largest amount of asteroids in our solar system. 78% of the main asteroid belt is a carbonaceous type of asteroids. The asteroid belt is where these crumbs of the solar system, where the leftover materials are. They are fragmented in smaller bits of things that maybe didn't quite form into planets, or were the materials for planets to snowball and form. I know we don't really get snow in Texas, but if you can imagine, if you push a snowball down a hill, it grabs material and gets larger and larger. We think this is in some part the way that planets formed, and that there was leftover material after planets formed, and now we kind of call these asteroids. The asteroid belt is located in between Mars and Jupiter, and the strong gravitational pull of Jupiter is what kind of organizes and maintains much of the solar system. So the location of the asteroid belt is largely due to the largest planet in our solar system, Jupiter. Now, sometimes these asteroids get kicked into the inner solar system, and they become what we call near-Earth asteroids. As I mentioned earlier, asteroid Bennu, where the return sample is coming from, is indeed a near-Earth asteroid. So something altered its orbit over time and kicked into the inner solar system. Not only are there 3 main material types of asteroids, but they also come in many shapes and sizes, fragmented and mostly non-spherical. Asteroid Bennu is a type of asteroid called a rubble pile. And if you look at images of Bennu, and actually I brought a little tiny baby Bennu with me. Hang on one sec. I brought a little tiny Bennu. And so it's this really oblong shape. But really, it's a mixture of different boulders and different grain sizes materials that are loosely attracted to one another through cohesive strengths and gravitational attraction. And this has created this sort of rocky rubble pile. If you look at the NASA images, you can go on that asteroidmission.org page, the homepage for the OSIRIS-REx mission. You'll see some great imagery where you'll see there's boulders the size of houses sticking off of Bennu, down to micrometer size grains all within the surface. This is quite small in the grand scheme of things. I believe it's 1,700 meters wide, if I remember correctly. And again, asteroids now that are left in the solar system are all pretty small. You might think of the classic dinosaur killer. This would be like 1,000 times bigger than asteroid Bennu. And so we still care about small asteroids. In fact, we want to know and track their orbits and if they're ever going to intersect Earth or fall under Earth, because it's all about location, location, location. If a small asteroid even hits one of the big towns in Texas, we got a big problem, right? It can release a lot of energy and be an explosive sort of reaction when they hit. Here's some more clapping in the distance. Sounds like people are excited out here. For those of you just joining, so you can barely see the streak of the incoming sample return. At first, it had a very vertical drop and then it planed out from a north to a south trajectory. It successfully landed at 8:52 a.m. local time here. I just heard a few minutes ago that they have recovered the parachute. That means they should be getting it on board, and there'll be 4 helicopters that will come out from this distance here. One of them will have the sample, one of them will be the NASA helicopter, and then us media will be able to have zoom in, and they should walk right by with that capsule. Got some questions here. Okay, so I saw a question of will the asteroid hit Earth? So it is not likely that asteroid Bennu will hit Earth. It is a near-Earth asteroid, or as we like to say, an NEA. So it does have a component where, as we orbit the sun, so does asteroid Bennu, but it also intersects the Earth orbit. And so any asteroid that intersects Earth orbit, we call a near-Earth asteroid. And again, these asteroids, I like to call them the crumbs of the solar system. They're the leftover material that have formed out of the planets long ago. You know, we're talking 4.85 billion years ago, just after the sun formation, where we have planets starting to form out of the leftover material in a big, what I like to call sideways snowball effect. And you can imagine, you know, you push the snowball downhill and grab more material along the way, and think that, in a sense, planets formed like this, but that there was leftover material. And that leftover material is now largely in the form of asteroids. The main asteroid belt is in between Mars and Jupiter, and we also have another asteroid belt out beyond the distance of Pluto. And you may have heard or noticed that we demoted Pluto, or rather astronomers demoted Pluto, to a Kuiper Belt object, or KBO, another painful astronomy acronym for you. There's sort of a second larger asteroid belt of material far out, and that was one of the arguments to call Pluto a Kuiper Belt object. But if you ask me, it's a dwarf planet. All right, let me check to see if you guys got any more questions I can answer while we wait. Okay, guys, I saw a few questions while we wait, and I also just checked on the NASA news. So currently they're using high resolution imagery to find SRC, or the Sample Return Capsule. They've located the parachute, and they're currently trying to locate the sample. It sort of landed in what they know to be a broad field, of course, and they need to actually find the sample. So this was a sample of the asteroid Bennu. I've got my tiny Bennu model here, and I've got a question on YouTube that I'll answer next. It's, could an asteroid hit Earth? Yes. This is in fact why this type of mission and this type of work is very important, because there are a lot of potentially hazardous asteroids. Another acronym for you, the PHAs, the potentially hazardous asteroids. I heard some cheering. They may have found the capsule. SRC has been located. Woo! All right, they found it hidden in the Utah desert there. So again, the OSIRIS-REx capsule, sample return capsule, the SRC. We could barely see it from our location here. It was quite faint, but it landed a couple miles out from where we're located. They've found it. They found the parachute first, and then they will load it up onto the helicopter, and we'll be flying here. We'll get a first snapshot view when it actually walks by. And this type of work is important. Someone asked, can an asteroid hit Earth? And yes, in fact, asteroids hit Earth quite commonly. We have lots of craters on Earth that we can study. There are sort of scaling physics that we can understand for how big of an impactor that hits to the scale size of the size crater that it could create from impacting occurring. So given a certain size material, we can have certain size craters that emerge. We have very large craters that we find very older geologic units on Earth. The most famous being a quote-unquote dinosaur killer, which at 66 million years ago on Earth, we see that the dinosaur fossils abruptly stop. Then there's a very particular defined layer of iridium. Iridium is a metal and has certain isotopes and ratios of the material. And although Earth has iridium, Earth has its own ratios and isotopes of iridium, and objects from space have a different sort of measurable difference, mostly in the isotope and the materials and the quantity that we have here on Earth. Iridium is a really, really low concentration on Earth, so it's really odd to find a geologic unit that was a very high concentration of iridium with very specific isotopes. And after the iridium layer on Earth, after 66 million years ago, of course, there's no large quantities of dinosaurs. Life kind of changes on the surface. Lots of debate on what actually happened with this, but at the very least, we can measure the crater that's in the Yucatan Peninsula, making up part of down in the Gulf of Mexico. And so there's lots of mapping of the craters. So we know that Earth gets hit. Now, I mentioned earlier that was a really big one, the dinosaur killer. We're really worried about smaller ones because of location. In fact, NASA has a campaign where some telescopes and some asteroid missions are purely focused on searching for the small asteroids, less than 100 meters wide, actually less than 80 meters wide. Because at some point, kind of the problem with our lens today for the size scale of the streak in the sky, the same thing can kind of happen with the size scale of telescopes. At some point, there are faint, dark, small objects that even big telescopes have a hard time seeing. And so the campaign to look for the more 80-meter diameter size asteroids are one of the prime focus for NASA missions. and is actually the prime focus of a newer office within NASA that focuses on planetary defense, the PDCO, the Planetary Defense Coordination Office. Yes, that's a real office of NASA, right? So this focuses on the more of the near-Earth asteroid and the potentially hazardous asteroids, the PHAs, and mapping them out. One mission that's also a neat asteroid mission is the DART, the Double Asteroid Redirect Test. So this is the Armageddon of asteroid test. This was last September, about a year ago. The DART spacecraft actually slammed into the binary asteroid system, Didymos and Dimorphos. And the whole point was that since we've got a binary asteroid system, we've got a small asteroid orbiting a big asteroid, we wanted to knock the big one to see if we can have a measurable change. If we can change the momentum of the asteroid, it actually will change the orbit. And so the DART mission shows yet again another potentially hazardous asteroid, something that could hit Earth one day, so that we could see if we whack it far enough when it's very far out from Earth, it only needs a smaller angle change to not actually hit us. This would be the opposite, which would be get us into trouble, where is if we didn't see a big asteroid or even something, like I said, 80 meters wide, if it hits in a downtown location, we've got really big issues. So small asteroids could do damage. But the more time that we know to have, so the further the asteroid out is, if we can hit it further out, it requires less force and it's a smaller angle change that we have to do. And so the DART mission is also pretty neat. The asteroid has still been spewing off material from the impact, which is pretty cool. You can watch the videos for that. They have the live stream, from the asteroid's perspective. This was a year ago in September, and you can see it get closer. The resolution opens up. You can see the rocks, the detail, and then boom, slams right into it. And so they've been measuring with telescopes ever since then to see how the trajectory of the orbit has changed. It has changed a measurable amount from what I have heard. So let me just check on things. Of course, we're waiting for that little sample of the asteroid Bennu to come back. See if y'all got questions. So we had a few questions there. Quite small and faint to see since we're further out. We're kind of the local. The entire history of OSIRIS-REx actually goes back over 20 years. There was a question of maybe why I'm here and what I have to do with the mission. So I've been an OSIRIS-REx ambassador for 11 years. I started as an undergraduate, volunteering for the mission, going to different schools, completing public outreach, teaching about the mission in its earliest phases once it was selected. Just as a quick history, the team from the University of Arizona submitted this in 2004 and was rejected. They submitted it in 2005 and was rejected. 2007, and they got close, but then they lost to the NASA mission named GRAIL, which GRAIL is really cool. It's a gravity measurement orbit around the moon. Okay, so we lost to GRAIL. That's fine. But then they resubmitted in 2011, and it was selected. And so since 2011, they've been on this cascade to build the spacecraft, to have all the teams. The spacecraft is built by Lockheed Martin, and there's a mixture of different instruments on board, both to do optical imagery, spectral imagery, radar mapping so that we understood the depth and the material. And what else they did to get higher resolution, while they were in orbit around the asteroid, they got closer and far out to get higher resolution. So they've actually got a range of scale sizes that you can see. Again, all of these NASA imageries are available in the nasa.gov gallery and also the asteroidmission.org gallery. You can see. So I've just been a person that's volunteered and really cared for the mission throughout all the years. And I got to go see it launch in September 2016. And of course, now barely got to see it fall, as if you were watching us, we had a hard time seeing the scale size from our location, but small streak in the sky. We'll also be doing a live stream for when some of the sample is being opened and investigated at NASA Johnson. That will be on October 11th in the morning. So you can check that live stream. NASA will be providing us with some B-roll footage. Someone asked if we just want to see something fall. So there was only a few select cameras that were allowed to be really close to the actual fall, and they will be supplying us with the imagery. So make sure that we post that for you. What I plan to do is to make a longer cohesive video. So we'll have going way back to some of the rocket launch in 2016, to some of the B-roll footage that we get from NASA for this event, combined with the sample opening event on October 11th. Just checking to see if I can hear any. We got some NASA updates in the distance. Okay. Don't quite hear anything yet. I'm going to check the YouTube to see if we got any more questions. Okay, so it sounds like NASA is completing some sweeps out on the area before they can take off. Again, the helicopters are going to come and land right here in front of us, and then they'll be passing by with the capsule, essentially where we can see with that asteroid Bennu. Okay, so we wait for our next update. A question about the primitive materials, and so exactly, this material is what we think to be some of the most primitive material of our solar system, meaning the asteroid Bennu hasn't gone through large geologic changes. It hasn't experienced planetary things like making a core or a mantle or a crust. It's essentially the original material that it always was. Probably a conglomeration of materials from the earliest parts of the solar system. A good comparison was JAXA's Hayabusa 2 mission, which returned last year a return sample of asteroid Ryugu. Asteroid Ryugu is also of carbonaceous nature, and in fact, the material was so pristine, it's related to or compares highly with the most primitive meteorite named the carbonaceous Ivuna, or the CI chondrites. We love to name meteorites after the location they fall, and a lot of them sort of get a typecast name given their location where they fall. Besides that, this CI type, the carbonaceous Ivuna type, CI type chondrites appear to be the most chemically similar to that of our star, the Sun, which leads us to that argument that it's really pristine material and really is some of the first leftover material from solar system formation. This is also why it's really critical that during sample opening at NASA Johnson, that it's in a complete clean room. Everyone's in bunny suits. Everyone will be under high cleaning order because we don't want to have any contamination from Earth enter the capsule immediately. We don't want anyone to sneeze on it, right? Of that nature. Okay, I'm going to check to see if there's more questions.
But anyway,
Okay, so NASA is completing the final checks on the capsule on the ground currently. We want to make sure there's no, vapor outgassing from the battery, anything of that nature. Completing the final checks, then we load it into the helicopter. We'll fly right here to get a close-up view of it. Okay, I see a comment that says, this isn't an asteroid, it's a spacecraft. Okay, so it's a spacecraft that has a capsule that has chunks of asteroid. So the name of the mission is OSIRIS-REx. The goal of the mission was to characterize, study, and grab a sample of the carbonaceous C-type asteroid named Bennu. It had a much less interesting name of a series of numbers. We sort of name asteroids by the number in which they're discovered per year. But for fun, NASA actually ran a campaign to have elementary school children enter the contest. And I believe it was some fourth grader somewhere in the United States that won. And so it was named Asteroid Bennu, which is a little bit more exciting. I've got a little tiny shape model of 3D printed model of Bennu here. You can see that it's a weird shape. Asteroids are lumpy. They are non-spherical. I like to call them the crumbs of the solar system. And the Touch and Go Sample Aquisition Mechanism, or TAGSAM, is the mechanical arm that actually came down on October 10th, 2020, and grabbed the sample material of the surface of the asteroid. Again, this is primitive carbonaceous material. It grabbed the sample, they backed out. They stayed in orbit, and they actually followed up reconnaissance orbits to look at what they did to the surface. It totally disrupted the location where they grabbed the sample from. This was from the Nightingale location that they chose. They narrowed it down from 4 locations. One major issue that I've seen, or a thing that came up during the mission that the scientists had to work really hard for, was we originally thought that Bennu was going to be covered in very small, fine grain. Think sand-sized grain, or even finer than that. And when they got to the asteroid, it turned out that it had boulders the size of 2-story houses on it, down to handheld, kind of river rock or cobble rock size, down to the micrometer scale size material. And so it'd be really interesting to see the distribution of grain sizes of the asteroid Bennu sample material that's in the SRC, the Sample Return Capsule. The capsule, again, just to update you all where we are, they're doing their final checks to make sure the battery that's inside isn't outgassing and causing any noxious gases. They're all wearing bunny suits out there. Again, we're at the Dugway Proving Ground. This is an Army base. You have limited or clearance, rather, to get out here. So it's a very special thing that we're able to even be at this location. The Sample Return Capsule at the top of the atmosphere at 8:41 a.m. It touched down by 8:52. We were able to, or rather my eye was able to see it only for a fraction, very small from this location. Sorry that the camera wasn't the best to pick that up, but we will provide and we'll make a post with the footage that the limited cameras that were near the sample falling location took. We'll get some shorts, we'll make some videos for you all to see that. But now we're kind of waiting for them to finish those final checks, to get that sample capsule loaded on the helicopters. The NASA helicopter will be one of them, and they'll fly right here, and we'll get an up-close view. And I'll check to see if we got some more user questions.
Okay.
Okay, so I saw a really cool question about, how you find if an asteroid crashes. Well, there's actually a little bit of a naming mechanism to consider here. So an asteroid is in orbit about the sun and out there in the solar system. If a chunk of an asteroid or a full asteroid itself enters our atmosphere, we change the name just to make it more confusing. We change it to a meteor. So when you see a little shooting star in the sky, know that it's not a star, right? We'd be really concerned with gravity of stars falling out of the sky. No, it's a little rock, it's a little meteor. When it touches the atmosphere, we call this a meteor. As it falls down, as it falls down, as it falls down, it feels the friction of the atmosphere. And a lot of meteors burn up completely. The material just completely disintegrates and never touches the surface. But if it makes it all the way down to the surface and strikes it, we call it a meteorite. Just to, again, make it a little bit more confusing. So it's an asteroid when it's still in space. It's a meteor as it's burning up through the atmosphere. And it's a meteorite when we go and collect it on the ground. There are just about 87,000 meteorites here on Earth. The way to test them is to do chemical, laboratory, and isotope characterization. We have to make sure it's not just, an earth rock that we wanted to pretend it was a meteorite. So there's a lot of chemical testing and isotope testing because the ratios of elements for rocks on Earth is different from ratios of elements from other things in space. And this even goes for Mars. This goes for the moon. In fact, we do have lunar meteorites and we do have Martian meteorites. And one of the main ways that we can test this is the chemical composition. So wherever it came from originally, whether it was an asteroid, whether it was a chunk of the moon, whether it was a chunk of Mars, when it touches the surface, it becomes a meteorite. And so the three main types of meteorites are carbonaceous, iron, and silicate. Most meteorites that make it down to Earth are of silicate nature. Carbonaceous is actually one of the most rare and the most expensive you could also purchase. You can imagine you can buy meteorites that have been found. The most expensive meteorite I know about is that carbonaceous Ivuna type I mentioned earlier, or the CI type, which is the most pristine. And one of the samples goes for $1,000 per microgram, so quite expensive. But what about finding it on the ground? So NASA maintains the Fireball network, which is pretty cool. It is web cameras and optical cameras that are placed all around the country and are triggerable by a bright flash. So a bright flash activates the camera. The camera knows to then collect the imagery or the data, and you get a frames per second. Depending on the camera, you can watch this little thing fall. And the idea is that you want to get a triangulation. You want to see from different point locations where that little meteor, and if it had hit the ground, became a meteorite, has fallen. And so if you get, 3 or more cameras that can see it, you can start to build a model. And so there's these models that use the Fireball network camera data and then triangulate to find where on the ground, where on the surface given some radius or sometimes, a polygon shape, whatever the shape is, they say, okay, somewhere in this 100-meter or maybe probably bigger, a couple 100-meter radius, we think it fell. And then this is a real job you can have. There are meteorite hunters. There are meteorite hunters that then look at that model data, look at where the area is, and immediately go get on a plane and go pick it up right away. There are people that as soon as it touches the ground are already booking their flight and trying to go wherever in the world it has landed. Now, unfortunately or fortunately, Earth's surface area, mostly ocean, water. So, many meteorites fall into the ocean and are unrecoverable. But if it lands on the surface area and we get a good triangulation from the fireball network, meteorite hunters can go pick them up and sell them to you, or you can buy them online, or you can also go see them at various centers. The NASA centers all usually have a few meteorites. The Smithsonian also has several meteorites. And so that's kind of the difference between the asteroid, the meteor, the meteorite, and how we find them. If you want to look at a lot of cool and trustable meteorites to purchase, one of the best places is the Tucson Gem and Minerals Show. The OSIRIS-REx mission is based out of Tucson, Arizona, at the University of Arizona. And every February, there are meteorite hunters that come to Tucson for a couple of weeks, and you can actually go shop and look at these meteorites firsthand, which is pretty neat. I'm going to just check on things and see if we got another question to answer.
Why does he want dual recording? I have
But he only has one adapter. So if you did an adapter and that camera, you can pull record. Well, first, let's figure out if it works. What kind of technique is we get for like now? Yeah.
No, it does it all the time.
Meaning, if recovery off goes as planned, it's supposed to take off in 50 minutes. It'll take all from here. We got to get the certain amount of fixtures, and then it probably has 2 minutes. 10, 12 minutes. and it drops off. So it goes straight over to the facility, but it's likely to land here.
Okay.
It'll fly by. They're not going to land it here, but it'll fly by as it goes to the ring. Right over there. The big one falls, but it flies by and you'll get that shot. It's not going to come here.
Okay.
Pretty comfortable.
That's fine. Okay. Thank you. All right, for those of us just joining, so gotten some updates here. They're still completing their final checks. So we kicked off a bit about an hour ago to be in the buzz for the sample landing. It was kind of hard to see from our distance and the scale size. We'll be providing some B-roll footage for that. What I'm going to do next is we're going to end this live stream, but when the helicopters fly by, I'm going to turn it back on. So I'll make a separate live stream that people can jump on. And then don't forget that we'll also be live streaming when it opened. So we will have footage for you from the more up-close cameras that were nearby that we'll be posting. And then we'll be turning this camera back on in just about 50 minutes from now. So I'll make another live stream link for everyone to jump on for when the helicopters pass by. I also heard word that hopefully the PI will pass by and maybe answer some questions. So if we got the PI on site for the OSIRIS-REx mission, I will also pan to that as well. So again, we're out here at the Dugway Proving Grounds. We're a couple miles out from where the return sample capsule from OSIRIS-REx, NASA's spacecraft mission, has landed. They're completing their final checks. I just heard that it'll take about 50 minutes for them to complete their final checks. They'll load it on the helicopters, and the helicopters will come right here, which we will live stream again. And then again, we're going to live stream on October 11th for more up-close sample viewing. Let me just see if there's any last questions I can answer. Okay, I see some other folk answering and saying some other things. Very cool. Yeah, those asteroids really, when meteorites enter, they really turn quite dark. So if you look at images of meteorites, they get that burn look on it. So luckily the sample return capsule has those heat shields around it, and so it was protected. So the sample inside is still pristine, still some of the most primitive solar system material ever to be returned to Earth. And again, we'll make a second live stream coming up for when the sample in the helicopters is passing right by. Thanks, everyone.